Number 1, the definition of range of a function is, quote, all numbers because you can put any number into a function. This is false. The range is the list of numbers, the list of values, let's say, that can come out of the function. Or you can also say the list of possible y values if y is the function of x. List of values that can come out of the function. The slope of the line through -7/8, -14/13, and -3/16, -6/7 is negative. Is this true or false? Well, let's look at the change in y. Here's the change in y. Right? So did y go up or down from -14/13 to -6/7? It in fact went up because this is less than -1 and this is -6/7 is greater than -14/13. It's greater than 1. So the change in y is positive, and the change in x is also positive because -7/8 is greater than -3/16. So this is positive. So the answer is false. So consider this line, 4x plus 7y is equal to -14. Find the equation of the line parallel to line 1 passing through this point. Put your answer in slope-intercept form. Well, what do we always want for any line? The first thing we're gunning for is that slope. So if we have 4x plus 7y is equal to -14, we do it step by step, plus 7y is equal to -14. If you subtract 7y from, or subtract 4x from both sides, you get 7 y is equal to -4x minus 14. Divide both sides by 7, and you can see right away that the slope of this line is -4/7. So we want the parallel line, so it's going to be the same slope, and we have a point 2, 1. So if you start with the point slope formula, so remember y minus y1, in this case that's the number 1, is equal to the slope times x minus x1, which is 2. You take this and change it to slope-intercept form, which is y equals mx plus p. So that's what our final solution should look like, that mx plus p. There's a lot of ways to manipulate this. The first thing Mr. Steiner likes to do is multiply everything by 7.
Mr. Steiner?
That's right. So on the left-hand side we have 7y minus 7 is equal to, remember let me put it over here, we're distributing a 7 over both sides, but remember this is 7 times -4/7 times x minus 2. So these 7's will cancel. We're left with -4 times x minus 2. And if we add 7 to both sides, I'm going to do 2 steps at once here. On the left-hand side, so over here we have 7y, because this plus 7 minus 7 cancels. And on the right-hand side, I'm going to look at this minus 4x equals -4x. We have -4 times a -2, which is +8 plus 7. And that's plus 15. So we're almost there. Dividing everything by 7 to get it in this, final form. Do it in orange. We're still gunning for that form. 7 divided by 7, we get y is equal to -4/7 x plus 15 over 7. Okay. For this one, a laser is fired from an elevation of 6 feet, so up here. It's fired down here. No, you cannot. And it is fired in a mirror that is 2 feet off the ground. So here's our mirror. The laser bounces off the mirror 4 feet away. So that's this distance right here is from here to here is 4 feet. The laser reflects off the mirror at the same angle it came in on. See the picture. Okay, so there we go. Look at all this stuff. Write either an absolute value function or a piecewise function that describes the path of the laser. Hopefully you recognize this as an absolute value function. I'm just going to draw an axis right here. And its lowest point is at x equals 4. So I immediately start thinking x minus 4 is going to be my vertex. And if you do a table of values, or just you can also remember that this vertical shift of plus 2 units would be right here. Now I told you that it comes in and leaves at the same angle, so the slopes are the same. So what is the slope of this line right here? It is, so it goes down 4 and runs 4, right? So that slope is -1, and then likewise this is going to be 4 by 4. So the coefficient here is just going to be a +1, which I won't write. So y is equal to the absolute value of x minus 4 plus 2. And you also just look at this as a table of values. Let's try x equals 4. What does y equal? Well, 4 minus 4 is 0. Absolute value of that is 0 plus 2 is 2. So that's this point right there. So let me do that on green. So this point right here is right here. And what about at x equals 0? So what about when we're on the y-axis? If x equals 0, we have 0 minus 4 is -4. Absolute value of -4 is +4. Plus 2 is 6. So here is our other point right there that we need. Okay. If we describe, so this is just as the absolute value. I said we could also do it as a piecewise, and a piecewise would look like this. We would have a from 0. Oh, and also, I'm sorry, we should also make sure we define this. And I hope you all remember this. This is for x greater than or equal to 0. And that will come in down here if you didn't put it as your definition right here, because I did not. This function does not exist for x less than 0. So let's do this for x from 0 to 4. It's this line. It's got a -1 slope, so a -x plus 6. And from, it's a crappy looking 6. Okay, and then from here forward, if you extended this line back, it would go through, I mean, you can kind of count it out, but it would go through -2. It would be x minus 2 from x greater than 4. And this could be greater than or equal to, and this could be, let's look at these two signs here. This one could be greater than or equal to, and then this one would be just less than, just so that point there is well defined. Okay, what's the domain of the function? All right, got a couple more seconds here. What's the domain? The domain is let's go to blue. The domain is all reals greater than x greater than or equal to 0. Right? Those are all the x's that can go into this function. And what are the y's that can go out? Remember, we look at that. Just put the horizontal line across here. Right? So if we look at these horizontal lines, which y values up here can be hit by the function? It is, whoops. What did I take away there? X greater than or equal to 0. The range is equal to all reals